Hi, everybody. I am Tracy Osimboni from the Massachusetts Department of Transportation in the Highway Division, where I am the Chief Administrative Officer. I'm excited to share with you today the work that we have done to develop a tool that helps us project staffing levels based on our capital and maintenance programs. So here we go. We developed a workforce strategic plan in 2021 to better prepare us to meet our changing future. The previous effort yielded a one-time estimate of staffing needs, but this did not result into a model that could be adjusted and run by the Highway Division to reflect our changing conditions. We wanted a tool that the department could run and adjust using results of the prior efforts as inputs inside of the tool. So today I am going to share with you our objectives for developing the tool, the process we followed, how the tool was developed, what our implementation was like, and lastly, the agency capability building results that we had attained from developing and implementing the tool. So objective-wise, we wanted a tool that was easy for our 6 district offices, as well as our headquarters staff and leadership to utilize for projecting staffing needs, to help us align staff and resources across our 6 districts, as well as our headquarters. And it was key that the users of the tools, which would be the district office and our headquarters, accept and understand the tool and its value. Most importantly, we really did not want to reinvent the wheel, and henceforth, we aimed to use valuable components from the 2021 effort. So I want to start off by sharing with you the process from need to implementation. So for efficiency, it was very important to us that we limited the time requirement from our leadership. We started with getting input from highway leadership. We made things more efficient by using as much of the materials that were produced to date. Again, we really did not want to reinvent the wheel. We wanted to use everything that we had had from previous efforts to really solidify what we were working on now. We were able to reproduce the results from the prior work, using it to obtain valuable parameters for the current effort, such as attrition rates and how these rates would vary by employee and tenure. Following this, we developed the methodology for using the tool. We developed the model for predicting minimum staffing levels. And after which, all of this was put into a spreadsheet tool for predicting staffing levels, as well as recommending new hires. And then we deployed this tool for use by all of our 6 districts, as well as our headquarters. We developed a draft tool which was tested with strategic users to ensure that we were getting the best feedback. After this, we rolled it all out to our entire highway division. Adjustments were later made based on inputs from prior users before finalizing the tool itself. So for assumptions, the tool recommends new hires by labor category and sections for highway headquarters, as well as our 6 district offices. It utilizes input details on current staffing levels, minimum number of staff required, targets, staffing levels, and various limitations on how many new staff will be hired in a year. When modeling new hiring, the tool tries to hire to achieve targeted staffing levels. It first prioritizes meeting minimum staffing levels. If these minimum staffing levels are achieved, it assumes additional hiring to achieve our target goals. The modeling is performed by district and labor categories, which are our sections, for each of our 14 labor categories and each of the 6 districts, as well as HQ. Now I'm going to go over the inputs that drove the model. Now, hiring limits can be defined in various ways. This includes whether new hires are restricted to replacing those that we have lost through attrition, and setting a maximum annual hires by number, by percentage, by labor category, or by the district itself. The model includes FTEs counts by tenure for each of our labor categories, as well as our district. which users can update with current data. A key feature is predicting minimum staffing levels, allowing districts and headquarter management to adjust model predictions and override factors, determining targeted FTEs based on a minimum staffing need. The tool also includes rates of employee resignations, retirement, and termination by tenure, which is actually our years of service. The default values are based on a prior statistical analysis, which users can override if this is required. The output of the tool include the predicted number of FTEs, new hires, minimum staffing levels, and target staffing levels. These measures are predicted all by the different labor categories, which are all listed below here. Now, this slide lists the parameters for the model for predicting needed bridge inspection staff. All of this is based on our inspection schedule. As you can see here, most bridges are inspected every 2 years, and poor bridges and tunnels are inspected weekly. Typically, we have 2 staff members participate in each inspection. The model actually assumes each inspection requires a minimum of 12 hours, including time for preparation, the actual inspection and reporting, and additional time can be required based on the size of the bridge or the tunnel or the asset in general. So this slide starts to talk about the modeling approach that we use for our maintenance labor. The review performed as part of the project really did not yield an existing model for predicting the need for labor. We realized through this process that predicting labor was one of our biggest challenges. So as a result of this, SpyPond did a literature search of existing research, and findings indicated that maintenance labor requirements varied very significantly across states and is really based on a large number of factors. Some of these factors include the size of the state's road network, the degree to which winter maintenance is required, the agency's approach to contracting maintenance work, particularly to the winter maintenance. And in Massachusetts, we do get a lot of snow. To obtain an estimate of minimum staffing levels, SpyPond analyzed the Bureau of Labor Statistics data on highway maintenance laborers by state, and then fit a set of models for predicting needed laborers as a function of interstate or expressway lane mileage and other lane mileage within the state. The tables on this slide show us the model's parameters and results in predictions. To fit the model for the highway division, SpyPond also examined the results for each state and tested different model approaches. Findings revealed to us that several states were outliers in how they staffed maintenance labor, which was in tune with what we had realized earlier on in this process. In the end, some of these states were excluded from the model, and data from other states were used for fitting the model. Now, this graph you're looking at shows lane miles and actual staffing by state. Although Massachusetts has significant weather maintenance needs, its staffing levels are not comparable to other states with very similar network sizes. 8 of the labor categories are specifically related to construction projects. As more construction work is performed within highway, more effort is required, which means more bodies are required for us to deliver this work. This includes project management, traffic control, and inspection. So we're not just talking about our construction folks, but everything else that supports the entire network. The recent NCHRP research performed on staffing requirements for construction was utilized to inform the modeling approach. So now I am going to turn this over to Bill Roberts from SpyPond Partners, who'd helped us to develop the tool for him to be able to provide us a demo and some more information on some of the literature.
The models for predicting construction-related workforce needs are based on NCHRP Report 923, Workforce Optimization Workbook for Transportation Construction Projects. This report has models for estimating full-time equivalents needed for managing capital projects. It provides estimates based on project size and complexity for 5 types of projects: road rehab and construction, bridge rehab and replacement, and other projects. The models are different depending on whether the project is small, medium, or large, and whether the complexity is low, medium, or high. In adapting the models from this report, we used the small project model values to figure out the minimum staffing requirements based on the number of capital projects. Then we fit linear models to the medium and large size projects to develop an estimate of staffing requirements based on the size of the capital program. In the staffing model, the result is the minimum of the 2 values. Other assumptions are inflation. The costs in the NCHRP report are from 2015, and they were inflated to $2022. And also for project complexity, we used the medium complexity to develop the models. To take the estimates obtained from the models, we obtained an overall number of construction management FTEs that were needed. Then we split this number between the different labor categories based on averages for MassDOT. And then to use the model, one needs to have the capital program by district for 5 different categories of work, and the number of projects by district for 5 different categories of work. So the 2024 to 2028 program was used for the initial data population, and there's an additional cost adjustment in the staffing model to account for the change in inflation from 2022 to the program year. This is a demonstration of the Massachusetts DOT staffing tool. The MassDOT staffing tool is a Microsoft Excel spreadsheet that's designed to predict staffing levels and new hires for the Massachusetts DOT. The tool predicts staffing levels and new hires for each of 14 different labor categories, also called sections, in each of 6 different engineering districts. The tool is organized into a set of tabs. The first tab is used to specify staffing inputs. It's organized into 4 different parts. In the first part of the staffing inputs, one specifies hire parameters. Here, one specifies a set of parameters that control the maximum number of hires in any given year, as well as the maximum number of new hires by year for each district and section. In part 2 of this tab, one puts information in on the capital program. This information is used to predict the number of staff required for construction-related labor categories. One table is used to specify by district the capital program in dollars for 5 different types of work: road rehab, road reconstruction, bridge rehab, bridge replacement, and other work. This information is specified by district. The second table in this section is used to specify the number of capital projects for the same categories of work, also specified for each district. In part 3 of this tab, one specifies various parameters related to full-time equivalents. The first table in this section is used to specify the number of existing full-time equivalents in each district for each section or labor category. The tool has information on existing staff and on the distribution of staff by tenure. However, districts can override the numbers in the tool with more current numbers. The second table in this section is used to specify the minimum number of FTEs for each labor category and for each district. Now, the tool includes models for predicting the required number of FTEs based on information like the construction program and the number of assets in the asset inventory. However, districts can specify adjustment factors to the model predictions in this table. In the next table, one performs the similar operation to enter override percentages on the target number of FTEs. This is also specified by labor category and by district. The final part of this tab is used to specify other parameters. The tool includes assumptions about the rate of employee resignation, retirement, and termination by employee tenure. This information is based on a statistical analysis of MassDOT staffing. However, a tool user can override the rates of resignation, retirement, and termination in this table. Once the user specifies all of this information, the tool can then be used to look at the results. The results tab has basic results for the whole state as well as for each district. The first table in this section has a prediction of target FTEs, minimum number of FTEs, and actual FTEs and new hires by year for each of 10 analysis years. Below it is a graph of this information, and then there's some tables with some additional details, including the actual minimum and target values by section for the initial year, the target hires by district and section in the initial year, and the 10-year gap between target FTEs and total FTEs by district and section. The Results by Section tab has additional details on the model results. Here, one chooses a district, or they can view the entire state and a particular labor section. This first table in this section then shows the number of staff predicted by year and the number of new hires for that labor section by year, as well as the number of staff and the number of hires for all sections for the selected district by year. This is followed by a set of graphs illustrating this information and a table that shows the actual minimum and target values by section for the initial year for the selected district. The tool includes several additional tabs, including parameters that are used to predict minimum number of FTEs, and then additional details on the model. One can use this information to see all the details about what's being predicted and to adjust the minimum staffing models. However, the tool is designed to allow a user to quickly obtain a prediction by just editing the staffing inputs on the first tab. And that concludes the demonstration of the MassDOT staffing tool.
Thank you very much for that demo, Bill. Now I'm going to wrap us through this presentation. Once we were happy with the initial tool, we had a district test the tool, and we also made sure that all districts' needs were addressed in the tool. Adjustments were then made based on all the findings that we had gotten from that interaction. After this, the tool was rolled out to all our districts and our headquarters. Most important to us was the valuable feedback and buy-in that we received from highway leadership. And this was due to a lot of collaboration throughout the entire process, listening to what their needs were, making sure we addressed them, what their concerns were, and also taking in a lot of that valuable feedback. So to end it all, we now have final projections for the current fiscal year. So we have a working tool that we're utilizing. However, a statewide hiring control was imposed and is actually still in effect. So we have not been able to use those minimum levels that we have acquired from using the tools and really start to put them in play. However, the tool is ready for us to use when these controls are lifted. So I'm here sharing this highway Mass DOT journey because now we have strengthened our agency's capabilities through developing a staffing tool. This tool is really going to help us as we go into the future. Now we have a more consistent method for project workforce needs across the entire agencies, which is based on our predicted workload. The tool empowers both our district and HQ staff and leadership to better prepare for the future, i.e. make sure we have an understanding of the number of personnel that we need to be able to deliver our capital program, as well as do our yearly maintenance. With it, we can collaborate across agency leadership to align staffing and workload and to ultimately optimize our operations. So with that, I want to really thank you guys for the opportunity to share our advancements with you. My details are right here on the slide. Please feel very free to reach out to me if you have any questions. And thank you so much for your time today.